Hello everyone, I am Professor Rachna Mahule and we are learning about the design and analysis of algorithm. Today we are going to start our third unit, which is based on greedy methods. In last unit we have learned about the divide and conquer method. In that we have learned multiple problems which can be solved by dividing the problem into multiple sub-problems and finding out the solution for that, and then we are going to combine all that solution into a single solution. That is what the divide and conquer method. Now we are going to start with the greedy method, and that greedy method can be applied to a wide variety of problems. For example, the problems have n inputs and requires us to obtain a subset of that satisfied some constraints. Of course, here we will have one problem and we have to solve it by using multiple solutions. We will have multiple solutions here, that is the any subset that satisfy the constraints is called feasible solution. We will have multiple solutions for a single very confusing or complex problem, and that solutions are called as feasible solutions. But that feasible solution is not necessarily the optimal solution. And here in greedy methods, we are going to find out what is the optimal solution or the best solution from all these solutions. So that is what the greedy method here. Now, the greedy method suggests that one can devise an algorithm which works in stages. In divide and conquer, we have multiple stages there, but actually that problem is divided into sub-problems. We have multiple sub-problems into the divide and conquer method, but in greedy method we are having multiple stages. Here that all are considering one input at a time. Different stages are there and we are considering only one input at a time. So at each stage a decision is made regarding whether or not a particular input is an optimal solution. We are going to find out this particular solution is optimal or not. So always we are going to find out this in greedy methods. And this is done by considering the input in a order determined by a selection procedure. Here we are going to select some here we have one condition by or constraint. By using that constraints we are going to just use or select this solutions here. So the actual selection procedure is also based on optimization measure. So here we will have the method is there, the procedure is there, select procedure is there, and by using that constraints we will select the feasible solution as an optimal solution. So here we will have multiple solutions. In that some are feasible solutions, means they are good for our problem. We can solve our problem by using that solutions. But from that, which is the best is called as optimal solution. So the value is greater. The actual output is proper or optimal when we are using this particular solution. That solution is called as optimal solution. So the greedy methods are depend on the optimal solutions. We are having multiple stages. In that we are going to find out the optimal solutions for a complex problem. So let's start with this greedy method. In this lecture we are going to learn about the general method, and then we are going to learn about the very first problem, which is the greedy method, which is the greedy type, that is the knapsack problem. So let's start with the general method here. So here we have the greedy method. In that we are finding out the we are going to optimize the problem here. It is called as optimization problem. It is a problem for searching the configuration. The set of configurations are there, and we are going to find one that minimize or maximize the objective function. Now, what is meant by objective function? Objective function is the solution for our problem. Now, here we are going for the minimize and maximize. Now, here when we are talking about the profits, most of the time what we are having one problem and we are thinking about the profits, and here the profit should be more with less efforts. So that is what here we have to maximize the profit and we have to minimize the efforts. Or suppose if we are talking about the money, at that time we need more money or more benefit and we need a less weight. Suppose we are talking about the knapsack problem, in that we are talking about the weight. If the object is having minimum less and maximum value, that will be chosen for our knapsack. So that is what here most of the time what we are having, we have to think about the profit. That is what the objective function here, and we have to always maximize the profit. If we are talking about the profits, we have to maximize the profit if we are having that objective function is profit. If our objective function is weight, or if our objective function is suppose the value or cost, it should be minimized. So that is what here we need the solution which will have the maximum profit and minimum cost for it or minimum weight for it. So that is what here we have to find out the optimal solution for our optimization problem, and that is solved by using the greedy method here. So of course we will have multiple choices, and that choices may be feasible choices. Now suppose if you are having the objects like for example you are choosing the objects for jewelry. Now for that jewelry what we are using gold, then silver, then fibers are also used, threads are also used there, then plastic is also used, then after that we are using different metals are also used there. So that is what these are the different things what we are using for jewelry. We are using pearls, simple low cost pearls will be there. So that is what these are the items by which we are going to create a jewelry. So what is our problem? Our problem is the creation of jewelry. What we are having? We are having the multiple solutions. That solution is nothing but the type of object what we are using for making this jewelry. Now here what we need profit. So that profit is actually the cost of your jewelry. It should be the profit by selling that jewelry, it's to be maximized. So you have to choose the particular object from all these objects. So of course you are going to choose the constraint. Suppose here I have given a constraint. That constraint is the metal. The object you can select, it should be a metal. Means what? Here you are having multiple choices for that problem. But the constraint is what you are going to select, it should be a metal. Now suppose here you have given the weights of that particular objects. For example, if we are talking about the gold, we will have suppose some grams, suppose 50 grams of the gold, right? So here we have 50 grams of gold, then the suppose 75 grams of silver, then 1 kg grams of that 1 kg of the pearls are there. So that is what here we have multiple solutions for our jewelry, but our constraint is what? It should be a metal. So the fiber, then the plastic, then the pearls, they are removed because they are not in our constraint. Our constraint is metal, so there will be two things are remaining, gold and silver. So what you are going to choose for your jewelry? Of course, you need the maximum cost when you sell it, and it should have minimum weight. So of course the gold is having the maximum value and the weight is minimum. So that is what here we can choose gold, so that in a small weight we can have a more value. We have more profit from that gold. So that is what here we are having. The feasible choices are there, multiple choices are there for jewelry, but we are selecting a single, or we are selecting some of them by using the constraint. So that constraint is a condition where we are choosing these solutions. So that solutions are feasible solutions. So that is what the gold and silver are the feasible solution, because they satisfy the condition. So that is what here we have the feasible solution, but the optimal solution is choosing a gold. That is, here we will have the maximum cost. When we sell it, we will get maximum profit from that, and we have the weight of that gold is only 50 grams. So that is what our solution. So we are always going to find out the best of all these possible feasible solutions. So that is what the greedy method. We are greedy about something, maybe profit, maybe weight, maybe both. So that is what the greedy method here. So I have already explained you about what is the greedy approach here. We are going to find out about we need to find out the optimal solution, and here it possesses a greedy choice property. Always we should be greedy about something. Now here the greedy approach is generally used when the problem is hard. Okay, so here we don't have a actual solution for that, but we will have the approximate solution for that problem. So that is what the greedy method here. Now let's talk about the general method of greedy problem. General method of the greedy approach. So here we can describe this greedy method abstractly. So but more precisely than above by considering the following control abstraction. We are using this following abstraction. Control abstraction is there. How we are going to select the actual solutions from multiple solutions. So here we are having the general method here. Just let's start with this procedure. Here the procedure is given, that is greedy. Now here A is the set of inputs. Here A, that is denoted by 1 and n, 1, 2, n, that is what the contains the n inputs here. So n inputs are there. So A is the set. In that we are having n number of inputs. Now here we are having the solution, and we are going to find out multiple feasible solutions here. Okay, so of course we are having the solution and we are initializing the solution to empty. Right now we don't have any solution for our problem, so here we are initializing it with 5, that is empty. Now here we are going to find out multiple solutions for our problem. For that purpose here we are initializing I from 1 to n. Now here we have multiple choices, n is the input here. So that is what here the feasible solution is given. Multiple set of solutions are given and we are going to find out which is feasible or not. If it is feasible, we are going to put into the solutions there. The union of solutions there means multiple feasible choices will be there. So here we are going to select A. Now here we are going to select A. The function select selects an input from A. This function select selects the input from A and removes it and assign it to value x. It is assigning the value to x. Now here we have the next function, that is the feasible. What it is checking? Feasible is the Boolean valued function. It is a Boolean valued function. It may be true or false. So that is what the Boolean value function, which determines if x can be included into the solution vector. That x, that is what we have chosen from this A, is feasible or not. If it is feasible, then it will be included into the solution set. So that is what, if x can be included into the solution vector, union actually combines x. Here union is actually combine x here with solution and update the objective function. It will update the objective function here. Okay, so that is what here we are having now one solution because x is feasible. So we are going to add it into the solution list. And here we have end if. End if means here we got the solution and then we are going for the second feasible solution. So here we have repeat and here we are going to again select from the particular A. We are going to select another procedure here. We are going to select another value from A here. Again we are going to check it is feasible. If it is feasible, you have to add it into the solution. Again we are going for the next. If it is feasible, we are going to add into the solution. So multiple values will be there in the solution. Now after that, here we are having greedy. Now greedy means what? The procedure greedy describes the essential way that a greedy based algorithm will look. So here we have the particular procedures are there. Select procedure is there, feasible procedure is there, union is there. The select is nothing but the constraint. We are going to select one of the solution from A. Then feasible, it will check the solution is feasible or not. And after that, we are going to put into the solutions, that is by using union. Union means combining the solutions here. So that is what we will have the multiple solutions for a single problem. Multiple feasible solutions for the single problem. And that is what here the greedy method. So always we are going to find out multiple feasible solutions here. That is greedy. We are not stopping with a single solution. We are going to choose multiple inputs here and we are going to find out the multiple feasible solutions, and from that feasible solution we are going to find out a one optimal solution for our problem. So that is what the greedy method here. Now the next is we have the knapsack problem. Now first we will see what is mean by knapsack. The knapsack is nothing but a bag. We know the meaning of sack here. Okay, sack means here we have the bag. Now what is actually the knapsack problem? Whenever we are talking about the bag, each and every bag will have the capacity. Okay, so we have to fill that much objects in the bag so that the bag will have to just make a full capacity. That is what it should be full. The bag should be full here. So okay, but when we are putting some objects into the bag, it not exceed the limit. Okay, suppose here our bag is there and bag is having the limit that is 10 kg. Right, suppose the bag is having the limit that is 10 kg. So that is what the capacity of the bag. Now here you have given some objects. So that objects are, suppose you are having 10 kg of gold, then 10 kg of silver and 10 kg of cotton, suppose. So you are going to put that into the bag. Now here one constraint is given. That constraint is you have to get maximum profit. The value should for that particular object should be high and the weight of that particular object should be low. Now suppose here you are having 10 kg of gold, 10 kg of silver, 10 kg of cotton. Of course, what you are going to put into your bag? The value is, the weight of the gold is 10 kg and weight of the silver is again 10 kg. Of course, your bag capacity is 10 kg. So you are going to put the gold into that bag so that you will get more and more profit, right? Of course, gold is more precious than the silver. So you are going to put gold into the bag. Suppose you are having the gold is having the suppose 8 kgs, you have gold 8 kgs and you are having 10 kgs of iron. Okay, so if you are having 10 kg of iron and here we are having the 8 kg of gold, so of course in your bag you are going to put 8 kg of gold because gold will give you more benefit than this iron. So that is what here we have the knapsack problem. We have given a bag, that is knapsack, and we have the capacity of that knapsack. Now here we have to put some objects into that, but what is our constraint? Our constraint is it should have minimum weight and maximum profit. Okay, so we have to put the objects which will give you the minimum weight and maximum profit. That type of objects we have to put into the bag. So that is what here we have the knapsack problem. Now the knapsack problem are having two types. One is the fractional knapsack, what is given here. So one has the fractional knapsack problem and second type is 0 by 1 knapsack problem, or it is also called as 0-1 knapsack problem. Now what is that knapsack problem? So in 0-1 knapsack problem we have the objects. Suppose we are having object 1, object 2 and object 3. 3 objects are there. We have to put these objects into the knapsack and that knapsack is having again the capacity. Suppose here we have put the capacity is suppose again 10. The weight of this object 1 is suppose 8 and the weight of this object 2 is suppose 4, okay, and the weight of this object 3 is suppose 5. And the cost of object 1 is greater, then the cost of object 2 is just below the object 1 and the least is object 3. So we have to put that object into the bag. So of course what we are going to put? We are going to put the object 1 into the bag and we are going to put the object, the capacity of the weight of the object 2 is 4 and we are going to put the object 4 there. But we can't put the 4 value in the bag because our capacity of bag is 10. We have already put this 8 into the bag, so remaining is 2 here. So we can put only the 2 objects there, or the object which is having capacity 2. We can put only 2 kgs of the object here. So here we have to fraction it, we have to divide it by 2, okay. If we are placing object 5 here, we have to divide it by 2, okay, because only 2 objects can be there into the bag. So that is what here we have to divide it. But the 0-1 problem can't allow it. We can't fraction that objects. We can't divide that objects into two. We have to put the whole object into the knapsack. That is called as 0 by 1 knapsack problem. But most of the time we are using fractional knapsack problem. Means what? If we are having multiple objects, we can put part of the object into a bag. Suppose I am having 10 values there, 10 objects having the cost having the weight that is suppose 8 kgs. I can put 2 kgs into the bag from this object. That is what fraction. We can put a part of the object into the bag. So that is called as the fractional knapsack problem. So the fractional knapsack problem is where we are given a set, that is S, of n atoms. N atoms or n objects will be there, and here each item I has the positive profit or benefit or value. The item is having its value, that is benefit or profit. Then it will have the positive weight, that is Wi. Okay. So here each item is having the profit, which is denoted by Pi, or we can say that benefit, which is denoted by Bi. Here it is having some weight, and the weight is denoted by small wi. Okay. And we wish to find the maximum benefit or profit here. We need to find maximum benefit or profit. We are going to put the objects into the bag, but that object only which will give you the more benefit. So that is what we are interested. Here the constraint is we need more benefit. And here the subset that doesn't exceed the weight W. The capacity of bag is W here. Most of the problem are having the capacity that is denoted by M. Remember this. Here in our example we are using N, and in our algorithm we are using W. Okay. So that is what the maximum weight, which is denoted by capital W, and the weight of the objects are given by the small w. Right. So here we have the weight of the bag, and it should not be exceeded by the weight of objects here. So here we can use a fraction of each atom. We can take arbitrary fraction of each atom. So that is called as fractional knapsack problem. But in 0, 1 we can't fraction our objects, our items. So that are the two types of knapsack problems, and we are talking about the fractional knapsack problem. So let's start with the fractional knapsack problem. In that some conditions are given. Here we can take amount xi. That amount means what? From 10 kgs I am using 2 kgs. Right? To fill it in the bag I am using only 2 kg. Some fraction or amount I am taking for filling the bag here. So that is denoted by xi. Here we have the item I such that the xi should be in the limit, that is 0 to wi. It is the w is the weight of the object. Suppose the weight of the object is 10 and I am choosing 8, it is allowed. 8 is xi here and wi is 10 here. Suppose I am having the wi is equal to 10 and I want to place it 11 and I want amount of 11, it is not allowed. Okay, so xi should be having the value which should be less than its original weight. For each I which is which is included in, which belongs to S, that is the set of inputs here, and all summation of xi should be less than w. W is the capacity of your bag, and xi, all xi's, all the weight of xi's, amount of xi should be less than the capacity of your bag. Then here we have the total benefit. So total benefit will be, here it will have the summation what objects we are placing in the bag, we are going to find out the summation of that. We will find out the summation of benefits from that objects, and that is denoted by benefit. And here we will have the amount of object and the weight of that object. Amount of object divided by weight of the object, and which is multiplied by benefit here. So that is what we are going to take summation of all the benefits which are going to be found by this particular fraction. How much amount we are using for that object and what is the weight of that object. So that is what the fractional knapsack problem. Now we will see the algorithm later. First we will see the example for this knapsack problem. So what is given in our example? Now see, here we have given the n. N is nothing but how many objects you are having. You are having 3 objects here. Then second is m. M is nothing but the capacity of your bag, that is knapsack. The knapsack capacity is 20. Most of the time it is denoted by capital W. Here we are denoting it by using M. Now after that we are having the objects, and that objects are object 1, object 2 and object 3. And here we are having P1, P2, P3, and that P1, P2, P3 are the profits. Right, or may have the values may have B1, B2, B3, that when we are calling it benefit. So that is what here we can choose profit or benefit. Any name should be will be there. So depending on that you have to put this variable P1, P2, P3 for profit, B1, B2, B3 for benefit. And the values for that is the object 1 is having the benefit 25. Then the object 2 is having the benefit 24. Object 3 is having the benefit, that is 15 here. Okay. So that is what here we have the profit or benefit. Now here we have the weights of that object. Small w1 means weight of the first object. So the total weight is given for object 1 is 18. The total weight for object 2 is 15 and the total weight of object 3 is 10. We cannot go beyond that. We can choose the objects only once. We can't go for doubling it. Okay. So that is what here we have 3 objects. Here it means the 10 objects for this particular atom will give you benefit 15. Then 15 weight of the item will give you benefit 24. The 18 weight of this item will give you benefit 25. Right? So here we have both the benefits and profit. Now we have to calculate the profit and the weight. Profit divided by weight. So that we can use it into the one greedy method. That is, when we are greedy about profit and weight, at that time we will choose this ratio. That is 25 divided by 18 is 1.3, then 24 divided by 15 is 1.6 and 15 divided by 10 is 1.5 here. So that is what we are having the benefit, the ratio here. Now here we have the greedy about. Now we will see 3 conditions here. We are going to find out the proper solution for this problem. So first, I am greedy about profit. I need more and more profit. So what I am going to choose? I am going to choose only the more profit item for my bag. Now what we are going to do? First is greedy about profit. So what is the profit? The maximum profit is the 25. Object 1 is having the maximum profit. So I am going to put that into my bag. So here I will have object 1. Object 1 is put into the bag, but the capacity of the bag is 18 and out of 20, and out of 20, 80 is now filled when we are putting object 1 here. Okay. Now what is remaining? The capacity of bag is only 2 remaining. Here we can put, suppose if we are talking about weight is equal to in kgs, so we have only 2 kgs are remaining for our bag. If we put 2 kgs of the item into our bag, it will be full. So what we have to choose? The second object. The second object is having the next greater profit. First highest profit is 25 and after that the highest profit is 24. Okay, so we are going to choose amount of 2 because our capacity remaining is 2. So we are choosing 2 here out of 15 weight. Out of 15 weight we are choosing 2 here, means out of 15 kg we are choosing only 2 kgs here, and the benefit from that we are getting 25. So when we, and the last one is 0 because object 3 we are not using in the profit. So that is what here it is plus 0. So that is equal to what amount we are getting, what profit we are getting is 28.2. When I am putting object 1 and object 2 here. The object 2 is in fraction. We are choosing only 2 from 15 here. So that is what here we are having the profits, that is equal to 28.2. Is it optimal? Can we put another objects which will give you more profit? So that is, we have to find out. Because we have talked about only profit here. We are thinking about only profit here. Now, the second solution will be, I am greedy about weight. The item which is having minimum weight, I am going to put it into the bag. Right? So here, I am going to choose the minimum weight and the profit here. So, what I am going to choose here, the weight of the object is the weight of the object is 15 here. Now the 15 is nothing but the profit. Here the weight of the object 3 is 10. So it is minimum. We are thinking about the minimum weight. I am greedy about the weight. So I am choosing minimum weight and maximum profit here. So here I am choosing 10 as a minimum weight. So profit I am getting from that is 15. Right? Now the second minimum weight is 15 and the profit from that is 24. But here if I am putting the object 3 here, sorry, so I am putting object 3 here, right? So what we are going to put, object 3 which is having the, it is the object 3 which is having the capacity 10. And how many capacity is remaining? The 10 capacity is remaining here. So we have put the object 3 which is having the profit 15. We already got the profit 15. Now we are having the minimum weight is 15 here. So we are going to put the object 2 here. But we can't put the whole object. The object weight is having 15, but we can't put the whole 15 here. We have to put only 10 parts from the 15 here. So, and the third object we have to just skip it because our bag is full now. So, when we calculate it, we are getting 31. The value or the benefit or profit we are getting from the weight when we are thinking about the weights here. So that is we are getting 31. So that is again is the optimal solution. We have to find out another solution for that. We can't say that this is the optimal solution. Although it is greater than this 28.2, it may be optimal or not. So we have to think about the another solution. The another solution what we are using is greedy about both. Now greedy about both means we have to think about the profit and weight. We need minimum weight and maximum profit. We are not thinking about the maximum profit as we have used in first. We can't go for the minimum weight as we have done in second. Now we are going to find out the third type of solution. In that we are greedy about both profit and the weight. We need minimum weight and maximum profit. For that we have chosen the actual ratios. So here the ratio is 1.3 for the first object, 1.6 for second object and 1.5 from the third object. Now 1.6 is the maximum. Here we are getting more profit. That is what, from 15 items only we are getting 24 profit here. See here we are having 18 items and we are getting only 25 benefit. In 15 items we are getting 24 benefit. It is more than this first object. So that is what here we are going to choose the highest first. Then we are going to choose 1.5 and lastly if we have the remaining capacity of the bag, then we are going for 1.3. So this Pi divided by Wi we have to use in sorted order. One we need is the highest index, then we are going for second highest index and then we are going for the third highest index. So that is what, first we will choose 1.6. Now 1.6 means what? We have put all the 15 items here from object 2. Okay, from object 2 we have put the 15 items in the bag. What is the minimum? What is the remaining capacity of the bag? The remaining capacity of the bag is 5 now. Okay. So here, what is the next highest index? The next highest index is 1.5. But we can't put all the 10 items here because the capacity remaining is 5 here. So we are going to put only 5 items out of these 10 items. And that is having the profit of what? 15. So the third item is again 0 here because we don't have any data. We don't have any capacity in the bag. We can't put any other object in the bag because our bag is now full. Knapsack is full here. And when we calculate all these, we are getting the profit of 31.5. That is more than these two. So here we can say that this is our optimal solution. These two are for only examples. Whenever we are talking about the knapsack problem, we have to think about all the parts here, that is profit and weight. Always we are greedy about this, both. So that is what here we have to choose the third option always. So that is what the knapsack problem here. I think you understand it. So now we can go for the actual knapsack problem algorithm. So here we have the fractional knapsack, that is S and W. S means the set where we have n number of inputs and W is the capacity of your bag. So here we have the input is the set S of items such as has positive benefit B1 and the positive weight Wi, and the maximum capacity is W. Now output what we are getting here, we have amount of Xi such that that maximize the total benefit. We need more profit than from this solution. Okay, but it should not exceed the weight that of bag, the knapsack. Now here we are going to find out all the solutions. So here we are using for loop. We should repeat always. We have put one item, then we have to repeat it for the second item until the bag is full. So here we are going for each item from S. We have to put the item here. That is Xi, the amount is initially 0. Then next is VI, that is nothing but BI divided by WI. We can say here PI divided by WI. So that is what profit and benefit. Here we can use BI or PI. So that is what here we have the value index of item I. That is what ratio we have found out, that is 1.6, 1.5 what we have used in the third solution. So that is what the actual indexed value. Then here we have the weight. Initially we don't have any weight, we have weight is equal to 0. Now we are going to repeat the steps while W less than capital W. Here we can use M also. So the weight of the item is less than W, means in the bag we can have the space to store the object. So until that we have to go for the repetition. So what we are going to do, remove from S item I having the highest value index. In our last example we are having highest value index, that is PI divided by WI is 1.6. So we are choosing that, we are removing that item from the list and we are putting it into the bag. Okay. Now here we are going to find out minimum of WI and W minus W. Minimum means here we have to check the bag is full or having the actual having the space in that. So from that we will get the remaining space in that bag. Then here we are going to put remaining space into XI, and here we have W is equal to W plus A. So that W is updated means here we will have the capacity. Suppose we have already put 15 amount in the bag, we will have remaining with the 5. Okay. So that is what we will have the selection from the actual set of problem. So that is what here we are choosing the highest index value, that is greedy choice. We need to more profit from less weight. Okay. So if there is space in the bag, then we are going to repeat this. Okay. So that is what here we are having the fractional knapsack problem. So that is what one of the widely used problem in the greedy method. So that is for today. Thank you.